right, so we are here. So this is a project I'm working on. And for example, for the continuous integration, I set up a workflow to build and test my code when, and then also on GitHub, I was able to set rules that prevented this code that is pushed from being merged until this workflow completes successfully. Until this workflow is successful. So GitHub Actions is basically a YAML file, it's like a configuration. So hold on. So a typical GitHub workflow file is contained in the .github folder in a repository. From the root of the repository, we have a .github folder and then a workflows folder. And you can have all sorts of workflows. So this end-to-end test workflow, for example, has a name field where I gave it its name. And then the condition for triggering it is here. I want it to trigger on pull request. Pull request is what normally happens when you push a code and you want to merge it to a branch. The merge hasn't happened yet, but you are requesting to merge. So what happens is that what you are trying to push and what is on a branch you are trying to push to is compared left to right. That's why it's called, it's the pull request, kind of requesting to merge into another branch. So this workflow was written to trigger when such an event happens. And if the branch you are trying to push to is develop branch, a branch called develop. So a workflow is also workflows running in most CI systems, workflows run in containers. So that besides that, you need to, in GitHub Actions, your workflows are defined by jobs. You can have multiple jobs and they could run in parallel or sequentially. Maybe one job runs after another, after one succeeds. So in this case, we have a job called test. We specify the image for the container to be Ubuntu latest and Ubuntu-like image. And then we now list out the steps. So the job is basically a list of steps. It's an array of steps to run in your process. So, and there are some steps that are already customized. They're like templates. You don't need to write everything yourself. They are like actions in the GitHub Actions ecosystem to do certain things you may want to do. For example, because I want to test the code in this repository, I'll need to clone or check out the code. So we have a workflow called, or action called checkout. So we define it in this step. So this step will clone the repository to your working directory. The next step here, because it's a Node.js application, we have an action that helps us set up Node.js. It also has other properties. It could give additional properties. For example, you could say version 18, 19 points, invalid. So yeah, I don't really necessarily remember what. So usually these actions have like a documentation page you can always view and find out parameters that they require. So you can always tell it the version of Node.js in case you need to lock it to a particular version. But if you don't, it will just assume you're referring to the latest version. So that's what happens here. Node.js is set up in your build pipeline. Because this application uses Redis for, it could be caching, it could be for queuing, whatever it is, we also need to set up Redis. Otherwise, our test won't work or it won't get access to resources it needs. It also uses MongoDB. So we set up a MongoDB as well. We have actions to do this. And then, so as of this point, these things are running in the environment, all ready to receive connections, this isolated process. So we also have what we call in backend applications, we have, in a system, we have what we call environment variables, which are like values you can get from the environment. And for backend applications, we usually use a .env file. And yeah. So because usually these things there are things that are contained in your env file, they are quite sensitive. They could be credentials to a database. They could be API keys. They could be anything. So GitHub Actions allows us to save sensitive information to a place in somewhere within the repository that we can refer to them from using the secrets object, and we specify the name of the secrets we want to read. So here I'm just echoing the contents of this secret and piping it into the base64 command and decoding it into a file. Because where we usually set this sensitive, where we usually set this sensitive values as strings, you get, but our application needs a file, so we still get to be creative. So these are cases where knowledge of bash will really help, because the value for run takes in a bash command. So it could also be in multiple lines if you add this separator symbol and then go to the next line here, for example. So moving on, because we are deploying to Google Cloud, well, we are not deploying yet, but because our application uses some infrastructure in Google Cloud, like S3 buckets, for example, you know, we will need to authenticate with something like a service account. There are other ways to authenticate with Google Cloud, but this is the way our application chooses to authenticate. And it's also a sensitive file. Hence, we are reading it from secrets. So after that, we install dependencies. Many of you can be familiar with this command, npm install, because we already have Node.js here. And then we now run our tests. npm run. It uses supertest for people familiar with Node.js frameworks. Just in case, I don't know if anyone is sending in messages. I can't see. All right. Hold on. Okay, sorry, I didn't see. So, okay, Git. On explaining Git, okay. Is the
mute everybody so that it won't interrupt the class.
Okay. All right, muted. Yeah. So Git is it's a software. In some is a software. It can be seen in, it can refer to it as a software. It's also kind of a database. So it's a software that versions everything you do. For example, let's say you want to write a book. Let's just forget about code for a moment. You want to write a file. You have a folder that contains different text files. Maybe this text file has your chapter 1, another text file has your chapter 2. So let's say on Monday, you just started chapter 1. You just type in your file and then you save. You can, if you are working within a GitHub repository, after saving your file, you can call this Git software to kind of store the entire state of your folder. If you had like 3 or 4 files in that folder, for example, Git can help you just take a snapshot of everything in that folder and store it as a record. That's what I mean. Like, we can also refer to Git as a database. And then when that's done, you can continue writing. Maybe you make another change, you save, you tell Git to version it again. It takes another snapshot. And, so you keep going on and on and on. You have multiple records. And in the case that maybe you realize you made a huge mistake and you don't even know how to retrace your steps, you can go to Git and tell it, okay, I want you to restore the state of everything in this file, in this folder, to how it was 3 or 4 days ago. And that's what Git can help you do. That's what Git is in a nutshell. And it's very important for developers because you write code every day. When you work with, even infrastructure, even not just developers, when you work with in an organization or you work with clients, they can always come to you and to make changes. Oh, I want this added, I want this removed, or I want this removed, and we don't need it anymore. And then sometime, maybe 2 weeks later, they come back and tell you to add what they asked you to remove 2 weeks ago. And it may be troublesome and all that, but if you have Git, because you're always taking snapshots of everything you've been doing, you can always roll back. You can go back, you can travel back in time and extract that particular component that you were asked to remove at it. You can go back to when you still have it, extract it there and bring it to the present. There are courses. Git is quite complex, but it's simple. I just gave a very simple explanation with, there are courses dedicated to Git, and I can find some online and share by the end of this class. So you could, really, there is one I took on Git that it's on plural sites. It's very, very informative. And I don't see you not knowing deep to a very large, very, very deep extent once you take that course. So yeah, that's what Git is. So back to you. After running this step, we do a cleanup job, because like I said, these workflows, or I haven't really mentioned that workflows are run on, in most cases, this process is running another in a computer or machine that doesn't belong to you, unless you deem it so. You can actually run this in the, have this execute in your own environment. But because this thing runs in, machines in the cloud that we do not have control over, it's always nice to clean up sensitive files. And that's why this command is here. And that's why this condition is specified here, so that even if anything fails here, this step will always run. So GitHub Actions has a large documentation. This is beyond the scope of this class, but this is just what it is in a nutshell. So this is like a simple continuous integration workflow for a Node.js backend application. And then for delivery, for example, it's similar. Here we have two jobs, which is the build and then deploy. But they are not normally by default. Two jobs run, they run in parallel, but we can make it run sequentially if we indicate to another job that it needs another job. So because you specify needs, it's going to wait for this to finish executing before for build, because the name of this job is build. So going to wait for the build to complete before this one takes on. And in the end, you can see this command, gcloud compute instances update container. So this is the part that actually deploys our application. This part builds, this job takes care of building a Docker image and pushing to an artifact registry, Docker push. In summary, here, clone, sets up the credentials, gets everything it needs, and then pushes to the infrastructure. So that's what continuous delivery is like in a nutshell. For infrastructure as code, in case none of you have seen a Terraform script, this is one, for example. This is a Google Cloud compute engine resource. This is from Google Cloud. So you can see one of the most important parts is like the zone, region and zone you are deploying this resource into, the machine type, E2 micro, it's usually, it differs from cloud providers to cloud provider. The name this year is the name what to call it, and many other things, startup scripts. If you're familiar with doing things on the user interface of cloud platforms, looking at the Terraform scripts would make sense. There's much more to it, but this is not the Terraform class. But it's just to give you an example of what it looks like. So I'm going to head back to the slide.
So I have a question.
Okay.
Okay, so from what you just showed us here, so I believe you are using the Terraform code to set up the instances on Google Cloud,
Yeah.
then Dockerizing it to run as an image on the instances, right?
Yeah.
Right, building it to run on instances, then deploying using GitHub Action.
Yeah.
That's just basic, right? Okay.
Yeah.
Just wanted to be clear. So you mentioned something about the secret. Why not? Are you not studying the secret? I thought GitHub Action has like a secret and variables that you can store your, since you're using Git flow. Sorry, deployment YAML. I'm using deployment something YAML. I don't know what the name you call it.
Yeah, it's a GitHub Actions workflow. It's
Oh,
usually defined YAML format.
okay, okay. So no, I
So
thought maybe you mentioned something about deleting the secret after or something on your script to clean up. Is it to clean up the instances on Git on Google Cloud, or I don't know? Maybe I
no,
didn't.
no, that's not what's happening. Let me share my screen again
Oh,
to clarify on that. A moment. So wow, to move to so for here. So the thing is, we are using GitHub. Yes, these are read from GitHub. This is gotten from GitHub secrets, right? But in our, they're actually strings.
yeah,
But what we need to run our application is actually a file. So actually, this secret is the content of a .env file. It's not even the content, it's just a .env file that was encoded in a base 64 format. And base 64 is a string. So if you reverse the process, it produces the file back. Do you
yes,
understand? So the reason we are cleaning up is that by the end of this process, we now have files in this environment that we don't need anymore at this point, after this is done. And because they are sensitive, we just delete the file. It doesn't mean we're not deleting the secret, we're just deleting the file that was like a byproduct or end product of decoding these secrets. And it's because your jobs are running, machine clusters. GitHub has like an array of machines in the cloud, virtual machine instances that all your workflows they run within them. So GitHub engineers or staff, they have access to this, not like they pick, I'm not saying GitHub is not secure, but it's just best practice. Do you understand what I'm saying? To
yes.
just clean up.
All right, thank you. I think that's what I wanted to get.
All right. Okay. That's fine. Let me go back to this slide. So 5 minutes left. So to summarize, we have code repository setup and CI/CD pipeline implementation. We saw a brief kind of example where you create a repository, you configure the CI/CD pipeline, which is your GitHub Actions. In the case of you using GitHub Actions, maybe if you're not using Jenkins or other CI/CD tools out there. If you are using external CI/CD tools, you would have to connect it to your GitHub repository. You have to authenticate these tools to GitHub so that they can have access to repositories and pull your code, because without pulling your code, I don't know what they are going to be doing. It's like carrying hoe, but you are going to the office, instead of to the farm, for example. So, and then you automate deployment, which you just saw. So, the cycle goes, once the code is pushed, you test, you test your code, you build it and you test, and if it passes, you deploy. That's pretty much what it is. And most of your job, the heavy part of the heavy lifting you have to do will be centered around your code repository setup and CI/CD pipeline implementation. You also have your job cut out for you on the infrastructure end of things, but things will begin to move on quickly once you are done with this area for your stakeholders. So infrastructure as code and configuration management, yeah, that's the next part. As you can see, there are two major parts you need to get accustomed with when it comes to DevOps: the code repository setup and CI/CD implementation, CI/CD pipeline implementation, and then infrastructure as code and configuration management, which I've given you an example of it. There are tools like Terraform, Ansible, Chef, and many of them. And then you also use Ansible. Ansible is one of the leading configuration management tool out there too. Not like you can't automate these things yourself too. Yeah, because even from first principles, you can use bash scripts to still do some of these things, but that depends on how much time you have, or how much hands-on you are. Okay. So next steps so you can look up resources online to move forward on your journey. You can actually search for courses on Udemy, for example, centered around DevOps, or you just search for courses around some of these tools, tool chains. For example, on this slide, you can look for courses around GitHub, Git, Docker, Podman, Kubernetes in particular, Terraform, Ansible. There are courses around them, so you can improve your knowledge on your skills on DevOps by focusing your knowledge you gather through learning about different tools and cloud platforms and cloud products and cloud platforms and all that. That's how you get better. And I mean, it's actually very easy to get better, because every day you practice, every day you are on the job, there is always something new to do. There's always something new to learn. You always learn every day. You also learn from developers, and developers will also learn from you as well. So with this, we come to the end of this class. Do I have any questions? 1 hour on the dot. So I guess not. Thank you everyone for having you. You guys were fun, really. And I hope I've been able to make an impact, to someone here or a group of people.
Yes,
So
sir.
with that, yeah.
Thank you very much. I'm very grateful.
Yeah, thank you as well. So with that, I'll be dropping off the call. Nice to meet you all. See you guys later. Bye.